Hi guys, welcome to part 5 of this series of videos on Dogen coding. This is actually a midweek session, so it's going to be a short one. However, we were accumulating a number of commits since our last session, so I thought we should just try to deal with them in a short session. These are commits that I do during my commute and so forth, so it's not convenient for me to record them. So last time, if you remember, we were valiantly attempting to detect cycles in our reference graph and failed miserably. And the problem was, if you remember, we had a DFS. Let's just have a quick look at the commit so you know what I'm talking about. So if we return back in time to around the 1st of November, sadly our builds still look quite red due to various failures of different operating systems. So around here we created our circular references validator, and we fixed the issues related to including the injector type on the model name. We did a couple of other fixes related to how the logger name was being propagated and so forth. But the very last bit of the video, we just concluded that the approach was not going to work at all. So just to recap where we were, we can just jump over to one of these commits. For example, this guy here. And if we browse the files at this commit, what we'll see is our approach at that time, which was copied from what we already had in our in the dia codes that did a graph. And so the approach at the time was to create, using boost graph, to create a DFS visitor, and the DFS visitor then was used to detect cycles. And when we tried to plug this in, lo and behold, the system just segfaulted. Now, of course, it's obvious in hindsight this would never work. The reason is because in BoostGraph, or at least the way we're using BoostGraph, not necessarily the only way to use BoostGraph, but given that we're not really expert users of BoostGraph, this is the way we tried using it. We first decided to build the graph, in other words, to add edges and so forth into the graph, and then we DFS the graph, we do a depth first search. And that basically means that if there's any cycles in the building process of the graph, of course, then, well, we will segfault. And it's exactly what's happening at the moment. We have a cycle in the graph, so in the building process, and that cycle is forcing us to loop around it infinitely until the computer just decides to give up. So clearly this approach is not a very successful one. So what we've done since that commit is we thought about the problem a little bit more, and we came up with a slightly more sensible solution to this, which is this series of commits you see here. Now, I'm not going to analyze individually each commit because it will take us too long, but I'm just going to talk about the final solution that we developed for this. So the first thing is we'll just jump over to the circular references. Well, actually, as you'll see, it's no longer called circular references validator, but just references validator. So I'll also explain. So we have a quick look at the implementation of the references validator now, and you can see it's actually quite simple. We have a method called DFS visit, and we have an entry method called validate. And then what do we do? Well, what we do is very simple. We basically take the data structure that we had before, which is, if you recall, contained a set of edges for each model, and I'm not entirely sure if we already have specific data structure for this. Actually, let's just have a quick look at where we were at that time. Yeah, so we didn't really have a data structure. Okay, so previously we were just relying on supplying the sort of the root vertex and the references, which are effectively the vertices, the edges for the references separately. So what we've done since then is we've decided to create a data structure to encapsulate that notion, which is our lovely reference graph data. and then we do a DFS visit directly on that graph. So what I'll do is I'll quickly just have a look at, let me just close these diagrams in case we are missing some updates here. And so if we have a quick look at injection, you can see here. So what we did is we decided that it actually warranted, instead of this being treated as just some kind of temporary data that we just generated and forgot all about, as we did before, and doing it just as part of the validation. On hindsight, it made more sense to treat this as a regular transform. The reason why is because we have other stories for which this data is also useful, as we'll see in a minute. So it kind of makes sense to just deal with that in a slightly more high-level, proper modeling way. So the reference graph data is a member of the model set, and we have a transform here, which is the reference graph data transform, whose job is to take the model set and to populate the reference graph data. Now, of course, you'll see that this is very trivial code. In fact, to be honest, if we go back to Git, in fact, that transform is nothing but copy and pasting of obtained references from model as we knew it. But nonetheless, it fits much better the architecture of Dogen, because now what we're saying is, as the last pass of the model set production chain, we obtain the reference graph data transform, and then we apply the validator, which is now called the reference validator, to the model set, and that will then do whatever validations it needs to do related to references. So if you have a look at the transform, you'll see, as I say, the transform is pretty trivial. All it is doing really is that method that we had before to gather all the reference related data, and then we just slot that in to the property that contains the reference graph data and then on the main model set production chain transform, we just need to make sure that we build the data for the reference graph, and then we just validate the reference graph. And once that's done, then we have this additional step here, which I'll explain in a second. So if we now quickly jump over to the reference validator. So how did we fix the issues that we had before? So what we've done is, so we decided to use two data structures to encapsulate the data that we need for DFS. The first data structure is a set, and the idea with the set is for every visit, for every DFS visit, in other words, every time we're going down until we hit the maximum depth, we want to keep track of everything that we've seen until then. That's why we need a set. That tells us all the references we've seen until then. And the list tells us the order in which we did the visit. So the set basically is how we detect whether there's a cycle, and the list is how we dump the path once we detected a cycle. Then what we do is we keep this DFS data in the stack, and as you see in a minute, this is an important detail. We keep it in the stack. Sorry, I've gone too far here. So we keep this in the stack, and every time we look through our references, we just make, in effect, a copy of the DFS data. And every time we unwind the stack, we go back to the previous copy of the DFS data. So this allows us a very, very simple way to backtrack as we finish a visit, as we finish reaching the depth, and we need to go back up one to the nodes to start visiting other nodes nearby. What we really want to do is we want to reset state, we want to backtrack state to that. And for this we use the stack itself to do the job, the hard work for us. And this is all kind of thoroughly commented so that we remember all this logic, so we're not going to forget next time we have a problem with this code. And in addition, and the reason why this is no longer called a circular references validator, we added a couple of new checks here that are, while we're at it, made sense to add. So the first check that we didn't have before is if you decide to make a reference to the model itself. This is a bug that happens every so often. We just, for whatever reason, get slightly confused, and inside of a model, say for example tracing, we add a reference to tracing. In the past this resulted in very, very strange error messages and some time spent trying to understand why. So it's actually really useful to just have a sanity check that says, are you referring to the model that you're on? Which is the simplest cycle I guess you can have. An additional check that's also quite useful is to detect duplicate references. So this is actually not a problem as such. Dogen will just detect as duplicate reference, load the model only once, but it's a bad sign if a user is referred to the same model more than once. It's probably a sign that they made a mistake somewhere. So, sorry, a bit thirsty. We also detect to see if there's any duplicates references in the same model. And so, given these additional checks that we've done here, we decided to drop the circular references prefix and just call a references validator. Seems to make a bit more sense. So at this point in time, we've now added a check to make sure we don't have circular references. Let's just, for the purpose of this demonstration, let's just show what happens. So if we, that's the easiest way to do this. So if I just go to compilation, and let's say I generate, let's just do Dogen.assets.dia, which is a fairly high level model. So as you can see, nothing particularly special happened here. What we'll do is, as well, for good measure, is we will ensure we have tracing on. I had to restart my Emacs quite sadly, so I've lost my areas. So what we'll do is we'll create a new area here for the logs. Now for logs it's convenient to have as much space as possible, so I'll get rid of 3 max for a second, and so the logs are going to be these guys here, which you know quite well. I'm just gonna open up the last time we generated the log so we can see what's going on here. Okay, so if I go back to so what we'll do is we are going to just go to the assets model, which is this guy here, officially freshly loaded after our git pull from our other machine, just to make sure we're not going back in time. And then if we just quite surreptitiously decide to add a reference here, and let's say that we add a reference to, say, in fact, to make this even more interesting, we will add a reference to the tracing model, which is a dependency or a reference model from the assets model. So we start, this is our first sort of demo of this. And so here we're going to say Dogen.assets. So now our assets model is referencing the tracing model, and the tracing model is referencing the assets model. So this is a very simple cycle. So now we just repeat the exercise we had a second ago, and you see it correctly detects the cycle. So it then is saying to say, okay, the assets model references the variability model, which references the tracing model, and the tracing model references the assets model. Now, if we go through the list of references in this model, we can see that the first reference is built-ins, followed by boost, followed by standard, followed by MASD, followed by MASD variability, followed by Dogen's profiles, followed by Dogen profiles. Sorry, I made a mistake here. We're looking at tracing. We should be looking at assets. Sorry, let's just repeat the same exercise. So first we have built-ins, then stud, then boost, Dogen variability, then Dogen.tracing. Now see, Dogen variability precedes Dogen.tracing. So Dogen variability then has a reference to tracing, and tracing, of course, as we've seen, as a reference to assets. So this is the first time the cycle occurs in that model, and that's where it gets detected. And then we have the exact path of where the cycle has occurred. And this is nice because then we can see, it gives us a clue as to where the problem's occurring. hopefully will make life easier to debug. You could also make another simpler cycle, I guess. It doesn't involve quite as many hops. You can go up to here, delete assets, and then we could say, well, assets model references tracing. Perhaps if we should say the variability model. So as you can see, there was obviously several, so 1, 2, 3, 4 steps. So we could say the variability model is referenced by us, Dogen.variability. So we can easily just go here and do exactly the same thing. Assets. Presumably we're going to see a slightly smaller path. So from assets we go to variability, variability we go to assets. So as you can see, this is an effective way to determine the cycle. For good measure, we'll just demonstrate the other checks that we're doing right now. So if I do Dogen.assets, so this is a self-reference. Hopefully we'll see it's being detected there. And of course, we don't just detect it on the first level of our visits. We could introduce it further down. So in this particular case, we could just say that the tracing model reference itself, and we still get the same support. So from assets we go into variability, from variability we go to tracing, and we know that that's the model that's referencing itself. So that seems to be an easy way to detect when things go wrong. And then of course, as I mentioned, the duplicate references. So if I then say Dogen.profiles, hopefully we'll see that there's a duplicate reference. Okay, so the most obvious errors now are getting picked up with regards to referencing. While we're doing this exercise, we also picked up something that was rather intriguing, which was, this is actually probably worth showing in the commits. While we were doing this work, we detected, or we figured out that we were inverting values in lists. This actually resulted in a large change to the generated code, as you can see by this commit. Now the change itself is actually very tiny. It's only one file here, and I'll show in a minute which file that is, which is this guy here. So when we're building a configuration, which is the guts of Dogen, for some rather unexplainable reason, we were pushing to the front instead of pushing to the back, which resulted that we were reading the metadata in reverse in a list. So in other words, if you look at something like references, instead of starting our references from, say, built-ins, boosts, stud, and so forth, we're starting from profiles, Dogen, which basically meant that all of the analysis that we're doing regarding the cycles was upside down. And one thing that we try very hard in Dogen is to try to process things as much as possible in the order that the users define them, because that then generates sort of a predictable output. The model will be generated using sort of the order given by the user, which makes things a lot easier when we're trying to troubleshoot things. So we ended up having to put in a fix for that, and that fix then resulted in, well, everything, single bit of metadata that's affected by lists was reordered. So things such as includes moved, the way that we were picking up databases, basically anything that was relying on the lists and ordering in the metadata. So that was an interesting problem, so we fixed that. And also while we're there, fixing these problems related to these issues, we thought that would probably be a good time as well to add some tracing information on this. Some stories we had in the backlog for quite a long time, and so I'll demonstrate this very quickly as well. So we'll just start with plain, I guess. So if I just enable tracing, I think it's plain the name of the option, and then if we just regenerate this model. Okay, it's done. And now if I just jump over to our area where the logs live, so what we'll see is tracing got generated. So as in the past, of course, we have the transform stats. Now we have an additional output, which is the references graph. And the references graph, it just basically dumps that graph data that we described before as a text file, so you can see the graph of references. But because we added support following the pattern that we had before of the different types of tracing data, we've also added in different formats. So for example, I'm not sure if there's a space in org mode. There is dash. So we have support for things like org modes, which is extremely convenient because you can use the usual org modes key bindings to look through your reference graph and explore it that way. Then enables you to have this sort of visualization of the reference graph. And last but not least, of course, we have GraphViz, which is probably a de facto visualization format for this kind of data. Don't think I have a shell, so what we'll do is we'll just hop over to area 7, create a shell here. Just rename this buffer something slightly more sensible, such as say Dogen shell. I think that would do. So if I just jump over to our Clang 9 directory, in the usual place where bright products get written, and we just generated this for the assets model, so still have problems with my Emacs key bindings. Haven't had the time to fix this. Right, as you can see here, we've generated a dot file, and then you can just use the usual commands such as PDF, if I remember my dot commands right, something like this. Always helps if you have dot installed. Always helps if you remember your root passwords. Emacs sometimes is a bit annoying actually, all this completion actually works against you. So if we just do something like apt-get install graph viz, it's actually larger than I expected. Right, so it seemed to have worked, and then let's just rely on Emacs. Oh, Emacs actually is opening Visualizer. So as you can see here, we generate a graph of the references, and it gives you very good visualization of how your models are linked together. This is a useful thing because you really want to see an acyclic graph here. You want to see a graph that looks healthy with some kind of layering that follows your design. So I think this is actually quite a useful thing in general. So once we completed that task, we more or less, well, let's just go back to our backlog and see how things look. If you remember, we were actually attempting to do something else, which was a relational model. We got slightly sidetracked with all of this. So we fixed the reverse order of the metadata, we fixed the cycles that we had, we figured out how to detect duplicate references, and we generated the model dependency graph. And then just as we were getting back into adding the relational model tracing support, for good measure, we just noticed that our perilous situation with the builds is getting even more perilous. So if you recall, at the moment our builds are looking very bad. We have very red in Windows, and this redness is all related to the fact that we don't really have ODB properly set up in Windows. If I recall correctly, we have got the wrong version of ODB. No, we don't even have any version at all of ODB, so it's just not liking it at all. Similarly, on Linux, we're struggling. Well, everything's fine on the Clang front end, but in GCC we're struggling with two problems, not just one. So at GCC we're struggling because we're just literally taking too long, and the builds are just taking too long. And OSX we're struggling both because we're taking too long, as you can see 49 minutes this build is always hitting the ceiling, but also because we have a different version of ODB. Interesting error here as well. But yeah, literally the problem we're having here is not so much that, but if we have a quick look at this chap here, we should be able to see that OSX is not very happy because the version of ODB is not quite right. So it's really not very good to be doing some heavy amounts of development when all the builds are read across the operative systems. So sadly, our next priority is to try to make the building of the relational model conditional and try to get these builds green before we can continue the relational tracing support. And in fact, we will also have to delete the tests just to get the build time down again, so we can build GCC again, because this is really not an ideal situation. So objective of this video in part 5 will be to try to make the building of the relational model optional, so that we can get those builds green again. So we'll start work on that story right now. Though to be fair, we have been working on this demo since probably past maybe. So it would not be fair not to do clock time on that. We'll create a story for that. Time production of videos, professional coding videos. So production time. What's the right name for this story? Time spent producing coding videos. Not really the best name, but let's just take that for now. I'm getting confused here. So if we say that we started around 21:30 perhaps, and then we'll just leave this story open. Story that captures time spent producing coding videos but not actually doing any development-related activities. Now, I think it's quite important to capture all the time you spend in a project, because you really want to have an accurate view of where your time's going, and in order to judge success or failure of an idea, you really need to actually capture the time you're spending on it. So it's fine to clock time against the story if you're actually working on the story, but if there's some kind of dead time, you really want your sprint to reflect that, so that you can, at the end of the sprint, when you're doing your post-mortem, you can then try to figure out whether it was a good investment or not. Right, so let's just focus on this story then. So let's just try to understand what we're trying to do here. First thing we have to keep in mind is that we already have the notion of options in CMake. So for instance, we've got Doxygen as an optional thing, LaTeX for our documentation is optional too, We have the option of doing minimal packages that just contain the binaries and not the tests. And we also detect whether JQ is available or not. And we have things like benchmark and boost test reporting, which we use for certain builds in CI. So it's very easy for us to just come here and say, well, we could say with relational support, add support for relational data, something like this. Interesting that some of these options have dots and others don't. And my OCD doesn't like that, so let's make sure they all have. Now this may not be the best of names, but it will do for now. And so let's just say that we start off with this being off, because it's going to be off on most platforms. And then what we want to do is to say, well, anything to do with relational, and really at the moment we mean ODB, should only kick in if the option is on. So if we're trying to build this with relational support, we'd like to detect ODB. And now what we'll do is, for now, is we'll say, if you try to build with relational support and you cannot find ODB, then, well, that seems pretty fatal, right? Because you asked for it and it didn't come. So that seems like a bad idea. The ODB executable, we can still leave that as optional, I guess. Reason being is that you may have a build machine that contains the ODB libraries but not the ODB executable. We just want to build, we don't care about running the ODB binary, so that's fine. The key thing is we just want to check that we don't include the relational model when you don't want to. And then let's just, for good measure, let's just check this is the right way of doing a with. Yeah, we've done it somewhere else, so that looks good. Now then, as you can see, we use this pattern quite often. So we can now say, well, if the relational support is not enabled, then we don't really want to add the relational project, right? And that is done in this CMake file. So we need to separate these cases here. So our user includes quite capturing everything here. And then we have the special case of the relational model, which is that guy there. And similarly, if we have relational model support, then we'd like to add the subdirectory. And if not, then, well, we shouldn't really. So the good thing about this is that we now isolated building such that if the relational model support is not on, then, well, we're not going to bother building it. And that's a good thing. This also means that we're not going to build this, or we could not build this in GCC, although to be honest I actually would like to build this in GCC, in Linux, Clang and GCC, just not on Windows and OS X for now. So this looks about right, just for good measure. Let's see what happens if I attempt to build right now. So because the option is off by default, as you can see, it triggers a build of the whole of Dogen, and hopefully what we'll see, I mean, I'll leave this running because it will take a little while. Hopefully what we'll see in a second is that the relational got excluded. Now, a second and related problem is, at some point we're gonna, when we start implementing this, we will going to need, in terms of tracing, we're gonna need something like a notion of a tracing backend. And at this level we'll have something like a relational tracing backend and a file-based tracing backend. Now, we don't really want to optionally not include tracing as a model, but we do need a way of saying, actually, the relational tracing backend is not available if the relational model is not available. So somewhere in the codes we will need a way to exclude the backend depending on what's available, what the builds had available for us. So this is what normally, if you're in the world of the configure scripts, the old configure scripts, there'll be a config.h that contains the things that were on and off, the features that were on and off when the product was generated. Now the way to do that in CMake, at least the old way, I'm sure that there probably is a better way these days, but the way to do that in CMake is to use configure file. And we already have a template, it's just that our template at the moment is only used for version. So what we need to do for this is we need to generalize this template, and instead of calling it version.hpp, we need to call this something like configure.hpp or config.hpp, and we also need to add here a Dogen relational model macro and define it if an option is available, and not define it if an option is not available. Now this is interesting because normally we tend to just use the value of a variable if that value is available, but we don't conditionally tend to define things. So I wonder what's the best way to do this in CMake. Maybe clearly we could do something like define, just to start off with, we could do something like Dogen relational model. Define, if I could spell. But of course this would always be defined, and well, let's just, for a good measure, let's just have a quick look at what do we think config.h from config.h and C. Just look at an example of a config.h, any would do really. Right, here we go. So the way these macros are defined is have. So presumably when we don't have something, we just set that to 0. So let's just interestingly enough, there's nothing that's not defined. Okay, interestingly enough, undef had read ahead. So in this particular case we seem to not define a macro, which is sensible. However, let's just have a look at CMake configure file. No. See if you can find some examples of how to use configure file. So there's a classic version. Know how to do that. Something a little bit more advanced. Just path. So the first example above allows variable to and after generating the file, the second example allows only variables to be defined using the @. Okay, not quite what we're looking for. See if Stack Overflow can help us. It's a question that we like. Now let's see. So these are similar to our example in that we don't seem to have a conditional interesting. Are you using CMake define or plain define? Well, clearly there's some kind of CMake define So copies an input file to other file. Each variable placed in the current file or the empty string if the variable is not defined. Furthermore, but see, there's always this is the thing with CMake. There's always something that does what you need. So if you do a CMake define and then the variable name, it does what we want. So let's just say we do CMake define, and then for good measure we will follow the convention that we just seen a second ago on configure, which I seem to have lost. So the convention seems to be to set this to 1. So Dogen have relational model 1, but we want it as a CMake define. Now then, I'm just going to leave this as version.hpp for now, and we can have a quick look at what the build is doing, and this looks good. So now if I just say relational, see, no mention of the word relational. Good measure if I run tests. Hopefully we'll see is the test will run. Interesting that we're still building certain things. I thought we had picked up all the builds, but there you go, the tests are completely green. Right, so we've achieved a way to exclude the option. Now what we'd like to do is we'd like to say, well, for Linux, this is an option that should be enabled really. So if I now go to my build files and look at my build.linux scripts, you see here a number of options. Now bear in mind we are in build.linux, so we don't have to worry about other operating systems here. So we could literally say, well, for Linux, this option is on, and that now allows us to rely on the option being on for Linux. So if I then rerun our scripts, now you see the number of targets has increased, and we did a full build again. CMake does not know what to do, so it just restarts the build from scratch. Now the other interesting thing is, because I restarted the builds, it's going to pick up this change here. So whilst the build's going on again, and again it's going to take a while, if I just go to outputs, and if I just locate the generated header file, which is here. Now that is interesting. No, actually that's expected. So presumably we need to make sure we've defined explicitly. Now let's just have to read a little bit more carefully what our friends were saying in Stack Overflow. We have to make sure that we've defined exactly the variable. So presumably in CMake we need to ensure what we'll do is we'll keep these two guys here. So if I go up to say the top level CMake, and if I just put my version, that should be here, so we can see what's happening with our files. So presumably, if we have that on, I think we could just basically set this guy here to 1, for instance. I don't think we need to do anything else. No, it's still quite far from a build, so we'll just restart our build. You see, Max is telling us the buffer has changed, so we go up to here, and see, lo and behold, it's done the right thing. It will generate the macro as you'd expect. And of course we've seen already that we don't have this macro here, but I mean, just for good measure, I'm just going to comment this out. And we start yet again our build. We'll see a second. Emacs is going to tell us file is changed, and you see it's changed here, correct. So that looks good. I'm just going to compile this with the right values. Now, of course, as you can imagine, version.hpp is included in a few places, so, and we don't really want to call it version.hpp either, so we'll have to change that in a second. But let's just do one thing at a time. So I think this is probably sufficient if the build succeeds, which it will. In fact, we know for sure it will succeed because this is a previous behavior, so I'm not going to spend any more time on this. This is the disadvantage of having short spaces of time, so what we'll do is we'll just say we think this looks good. We'll ship this and see what the build machine says. So let's not touch any of these models, and let's just be very careful as to what we're committing, because we have changed login options as well. Here we are. So let's not pick up any of the login changes. That looks good. That looks good as well. So just to double check here. This looks good. This looks good too. And the final result is merely stuff related to ODB on the main CMake file. And then on the second CMake file, this is why sometimes it's good to have a bigger view of the Magit buffer. On the CMake file for projects, we see also that we've just excluded the relational product, so that looks good. We clock some time here, so that looks fine. And we enabled this option, and we had this space there for the next. So I think that all looks fine. So I think for this one, we could say something like CMake add option to make relational model. Make relational model optional. Enable relational model on Linux builds. I mean, this is where sometimes I get a little bit pedantic. I mean, you could really do two commits here, one for the build script and one for CMake, but I think that's alright. Also say templates add macro to detect presence relation model, and that looks good. So what we'll do is we're just going to ship these two options, and the reason why is because we want to kick off the Windows and the OS X builds just to see what it does, because likely we're going to have some kind of problems in build machine, and that's probably going to take a while until we get there, and we might as well just keep that going so we don't wait until this is done. So we've done the first bit of the work. The second bit of the work is to figure out what to do with these files here. First, we probably will start by renaming the templates to config. That looks about right. And once we rename the template, of course, you have to be careful. Everyone that's referring to that template refers to the new name. So I guess the easiest way to do that is to just go to projects, do a grep for version.hpp. It helps if you grep correctly. But see, there's a few mentions of it, so I mean, this is where I guess sometimes it's helpful to be a power user, Emacs power user, because you could go around and start faffing around and trying to look at all the references. But another way of doing this is just to jump over to a new area. Let's just call this area grep. Get our grep up again, and then we can just do grep. Choose this guy here. And then if we just replace version config, we more or less achieve what we're looking for. And then we can just save this. And Emacs is obviously taking a bit longer because it's loading Clang. And we're gonna finish edits. Good. Okay, so this is nice. Now if I just go over to compilation, if I say please rebuild the whole of Emacs, Dogen, now this succeeded. However, one thing that's probably worthwhile checking is whether we are not secretly still relying on that file. So if I look at the generated files, it includes, you see there's still a version here, so just delete that for good measure. And now let's run the compilation again, and this is good. And then if we just run all tests, so that's a bit nicer, isn't it? Because, I mean, what we're saying now is, since that file no longer contains just version stuff, we want to call it something a bit more meaningful. So now if we just have a quick look at the diff, and of course bear in mind that we forgot to clock the time for, since we last clocked. So let's just call it 18. I'm happy enough that this story is completed. I mean, we can open it again if you see the builds fell, but I'm happy enough for now. This is going to work. And if it doesn't, of course, we can always resume where we left off. So we're just going to jump over to Git and look at the changes we've made. You can see it's all very straightforward. And of course the time we clocked. And you can just say something like rename generated version file to config. That should be since we now have more version information in this file, it's probably best to rename it to something more general. Okay, and that should give us some idea what we did and why we did this. Now let's just hop over very quickly to the builds, because sometimes you find that the build machine is stuck doing something that's not very useful when we're waiting for a build. It's actually important to us. So this particular case looks like it's only doing useful work, so that's all good. Now I'm just gonna go back to our projects and just jump over to Windows. Now the Windows build is failing after a minute, so that looks a little bit more promising. So as you can see, we're now going past the configuration of that, and it seems to be at least attempting to build. So there's some hope here that we might end up with a green Windows build. So the last problem we have to face is the issue of having tests executing on the GCC build, and those tests are the main reason why the GCC build is taking so long. So and in fact even the OS X build is also problematic now. So if I just have a quick look at our last run, it see we have 3 breaches here of our maximum time, so we're just basically taking too long. As I explained in the previous video, the right solution for this is going to be to create some kind of metadata override. Now this is not exactly a trivial thing to do. In fact, let's just jump over to our backlog and see what our notes say. We have a story here for this. Generate ORM tests. Schema name on ORM should be transitive. What departments not populate schema.set? Consider renaming origin types. In fact, I can't actually see this story. I wonder if we put it in the backlog. Modeling error, testing facet, simplify implementation, consider merging. Seems to be miscellaneous. Pretty sure we captured this story somewhere. But it could have been somewhere not very obvious. So, in this sort of situations, the easiest thing to do is to just search for some keywords. So, add support for decoration configuration overrides. That's not it. Allow users to override string prefixes. That's not it either. So, override seems like a good name for this story. So let's keep searching for overrides. So it's not as a story name. Let's just look for override in general. Fortunately, we probably have a lot of mentions of the word overrides. Okay, let's look for stories with metadata. We definitely had a story for this. Perhaps something with profile. Nothing obvious. Let's think about this. What would we call this story? Maybe if we just have a quick look at the ideas around this at the time. So we have a profile model for Dogen. What we're trying to do at the moment is we're trying to create something like a enable all facets profile here, and then of course there's a metadata entry here for every model that determines what profile we're using. As you can see here, variability.profile, and that's pointing at the moment to the default profile, which is this guy here. But if we had another profile here that enables all facets, and if you could override that on load, then we would generate everything. And that seems like a simple approach. So overrides is a good keyword for this. I'm surprised that doesn't catch anything. Let's try overrides. No, we tried it here already, didn't we? Profile, perhaps. This is very, very strange. I'm convinced that we had a story for this. Something not quite right happening here with our sprint backlog at the moment. Well, just for now, what we'll do is we'll just create a new story. Oh, actually, one thing we could search for as well is builds, anything related to builds. Consider creating, here we are. Consider creating a test build for all facets. I wonder if Yes, this is the story we were talking about. And if I just do a git blame, this might take a while, sadly, because this is a very large buffer, but I would like to know the commit for this particular line. Seems recent. Yeah, sadly this is a really long file, thousands of lines long, so git blame might just take a while. It's a shame because this is really where it's useful. Just wanted to know our recent. There's no way of doing this, isn't there? Can we just ask it to give up? This is where Emacs synchronous nature is a little bit annoying. You do something silly like git blaming a 700k file, and then there's no easy way to tell Emacs not to do it. That's a bit stuck, sadly, in these sort of situations. But well, I guess one thing we can do while we wait for Emacs to sort itself out is to have a quick look at the story. So consider creating a test build for all facets. This is exactly what we want. So we can't afford to generate test code in Dogen for the continuous builds because we don't have enough build time to compile all generated code. Okay, this is exactly the problem we have. This is true when we're just generating a few facets. However, we definitely want to generate test generated code in real models. So here we are. So we need to allow variability overrides. So the idea was to create a command line flag variability override, misspelled here, and I think it's also annoying is that you can't close the file either. The solution for this to allow variability overrides, yes, correct. So we need to create a new command line flag, variability override. Not sure about the name, to be honest. Variability override. It takes a triplet in the form of element ID, the key, and the value. So we parse these elements into a container. Interestingly enough, we can't override attributes with this approach. As you can imagine, you can also supply properties or metadata at attribute level. So for instance, if you take any of these profiles, in fact, you'll see that these attributes contain metadata. So in an ideal world, you would want to be able to do that. You know, you want a generic solution so that in 6 months' time, we don't need to come up with yet another approach for this. But in the world we live in, we might just have to start with that. So we have the element ID, key, value. Parse these triplets into a container and then use it in the variability transforms. For the scalar values, we merely override the value. For collections, we push back. So this will allow you, for example, to add references. If you cannot find the target element, we throw. Exactly, this makes sense. Okay, so this sounds like a good approach for this. So we've already done all the hard work. And see, this is another thing we see a lot in Dogen. Many of the stories evolve over long periods of time. I mean, you can probably see here that there's, I mean, look, it's blame is still going, but you can probably see here that we have multiple colors because this story was edited probably several times over this lifetime, and some stories probably they could remain in the backlog for even years. But every time we have an idea, we go back to that story and we add some more detail to the story until it gets to the point where we need to get the story off the backlog for whatever reason. So in this particular case, we would not touch the story were it not for the fact that we're now getting to red builds all over the place. Now continuous builds are important. So you can't really be hacking some fundamental parts of your system without your continuous builds being green. This is really not ideal. So for these sort of cases, we really want to make sure before you start doing serious work that your PC's, your continuous build is telling you the truth. It's also important your Emacs is telling you the truth. I wonder if there's a way to, well, I don't want to kill. This is a pretty powerful machine. I would have thought blame like this wouldn't take forever, but clearly even then. This is definitely one of the main issues with Emacs, not being very good with multiple threads and asynchronous work. Could issue a kill signal. It is the only problem with being a Emacs user is that you start building up state over time, and even though with most Emacs users have got ways of saving that state, it's always very painful when we have to restart Emacs, because this is all sorts of things that are in memory that never get saved correctly, or at least I haven't spent the time required to get my Emacs in that state. Right, okay, this is really not working, so I'm gonna have to resort to some signals, I'm afraid. So the first thing you do if you've got Emacs in the state is to try to send USR1 over to the process. Now this sometimes gets Emacs out of its funk. That doesn't work. I believe it's a USR2, which will take you to the debugger. In here, what we can do, Emacs is still a little bit not quite its old self, but sometimes one is able to get it back up. Sadly, it does not look like this is one of those times. As you can see, there's a lot of calls to Git to do the display. So I think, for the interest of brevity, I'm just gonna do the thing I'd like to do the least, which is a proper full-blown kill. And as you see, even the music is gone because everything relies on Emacs in this place. I'll just restart Emacs for now. And what I'll do is set background color to black. And oh, sorry, let me just get a second window so that it's visible here. Right, so as you can see now, there's no working errors in my Emacs, and because we killed -9, we lost our history because it didn't get saved on exit. So well. We will just very quickly, well, I can't really code without music, so the first thing I guess is to just get our bongo going and take us back to some FM. And we can save this area here. Oh, actually, one thing I don't particularly like is oops, if I could spell bongo. Okay, I don't really like my area one taken. This is where I normally put my code in. So if we just go back to consulting, Dogen integration. Okay, so just get Tremax up and running. Right, so what we'll do is just to finish this video, because we're also running out of time slightly. We will just I'm just going to very quickly get our products backlog. Right, so we located the story, and if you remember, the story was under build, something to do with build. Right, so what we'll do is we just grab this story here, move it over to our sprint backlog, which is just a signal that we're now going to be looking into this story. We'll also look at how much time we spent in this analysis. So pretty much all the time from completing this story here was spent in some kind of backlog grooming, as shall we call it. And we'll just clock time for that. And what we'll do is we'll just say, well, agile backlog groom. And this is basically to capture the time we spent messing around there. Okay, so just to summarize what we've achieved in this video then. So we've had a quick review of the commits that have been done between the last video and this video, explaining the solutions that we came to the problems of circular references and detecting other problems with references, and that was done. We also tried to solve the problem of not being able to build on OS X and in Windows because our VC package exports are not up to date there. They don't have the right version of ODB. So just to get us going, we made the relational model optional so that we can at least continue to generate Dogen packages. We also looked into the config so that in the future we can make the rest of the code optional, not just the CMake level. And finally, we started looking into solving the problem of taking too long to build in some of our configurations, such as GCC. So now, over the next few days, I will be implementing the work to make the overrides work, in fact. And so hopefully on the next video we'll discuss how that work is being implemented and ways of updating our nightly builds to take into advantage the overrides. Because what we'll do is we'll remove all the generated tests from the CI, from the regular CI, and only use that in the nightly build via the overrides. So that's pretty much all for today. Thanks for watching.